All right, so this is mainly about concepts on stuff like accuracy, precision, and significant figures. If you've already got that down, there's another video that I'm going to recommend that we'll be posting as well. But if you're not quite clear on the concepts of accuracy and precision, significant figures, this is where you need to be. All right, so first off, before we even talk about significant figures, we need to cover accuracy and precision just a little bit, because some of the concepts there are going to come in handy later. Now, the terms accuracy and precision in everyday speech usually mean about the same thing, and there's nothing at all wrong with that. But in science, it's going to be a little bit different. There's specific definitions. First, and both of them are pretty easy. The first one, which is accuracy, which is how close a measurement is to the accepted value or to the correct answer. And then precision, which is how close the repeated measurements are to each other. How, sometimes I've heard the term reproducible, informally, reproducibility. Anyway, so again, accuracy is how close you are to the right number, and precision is how repeatable it is. So it seems like that there's a law that if you're teaching this stuff, you have to use targets in teaching it. And it is actually pretty useful. If you look at A, B, and C, if you look at A, you've got all the hits from on the bullseye. They're all on the bullseye, and they're all very, very close together. So you've got something there. It's an example of something both accurate and precise. And since in everyday speech we tend to use that as a synonym, that's maybe not even all that surprising. But you've got something different over on B. You've got something. All the hits are right next to one another. They're all clustered up together, but they're nowhere near the bullseye. So that's something where you get something that's precise, but it's not accurate, and that's not terminology we typically use in everyday speech. But it's something that's important in science. And then probably the one that's about the easiest up here to see is the last one, which is neither accurate nor precise. The values are all over the place. The hits are all over the place, and they're nowhere near the bullseye. All right, so we needed that in order to talk about significant figures. And significant figures, the definition, actually several different ways to word it, but here it says they're used to show how certain we are about measurement. That is, how close they really are to what they're supposed to represent. It says they're the digits of a number used to express a known degree of accuracy. So accuracy, again, meaning how close it is to the right number. So an example I would give on this one is, say, what if I told you the population of the United States right now is 333,131,197 people exactly at this exact moment? Would that seem like that was, reasonable or not? And even if you didn't know the statistics, I actually looked them up, but according to, the search I did, there's something like 7 babies born every minute in the United States, and about 5 people die. So obviously the population number is going to be bouncing all over the place on that scale. And already that that's sort of, okay, yeah, that's probably in about the right ballpark, but you can't claim that level of accuracy on it. Okay, so here is another example. What if I said the distance from Atlanta to New Orleans is 468.918 miles? Well, that's about the right distance. It's, according to Google Maps, somewhere around 468.9. But the 1 and the 8 part, the 1 is in the hundredths place and the 8 is in the thousandths place. And 1/1000th of a mile is like 5 feet. All right? I assure you that nobody has measured the distance between those cities with that degree of accuracy. So, okay, that's about the right answer, but if you're claiming out to the thousandths place, that's just not valid. All right? That's not even beginning to represent reality, a degree of accuracy that's simply not true. All right, so we're going to do another little exercise here where we've got an example of measuring something with as much accuracy as possible. And I'm going to do a baby alligator as an example because we're in Louisiana. So our goal is going to be to measure the baby alligator as accurately as we can and then determine how many significant figures we should use. All right. So we're in a biology lab. We want to measure the baby alligator. And so we're going to line up the end of it close to the tail, the 0 notch close to the tail, and then try to read the measurement off the end of his nose. So we line it up like this, and at first glance, it looks like it's in the ballpark of about 24 centimeters or so. You can see the 24. But we need to do a little bit better than that. We can get closer. And of course, since it's just a baby alligator instead of an adult, the fact that it's a cartoon doesn't hurt either, we can get in really close. And when we do, we see that it's between about 23 centimeters and 24 centimeters, much, much closer to 24. And how much more detail that we can get out of this is the whole purpose of this whole discussion. What can we say about how exact can we get on the measurement for this baby alligator? So again, if we look closer and we count the notches after 23.5 centimeters, so 23.5 is right there, is about right there. We see 0.6, 0.7, 0.8, 0.9. So it's just a little bit over 0.9. So it's a little bit over 23.9, but less than 24. And the idea is that the point between these two values, that is, as it says on the screen, it's the limit at which we can accurately measure. And it's where we find what's called the estimated digit. And the estimated digit is exactly what it says. We have to estimate it because if no other reason, there's no notch there. And again, that's the limit of where we can accurately measure. So just looking at it, just eyeballing it, it looks like it falls slightly less than halfway between the two. And we know it's not quite 23.95, so we're going to call it 23.94. All right. That last digit, again, is the estimated digit. And it's extremely important because there's very often mistakes on this. Just not realizing the fact that significant figures include all the digits that are known, plus that last one, which is estimated. The fact that the estimated digit is a significant figure will throw people sometimes. All right. And that wraps it up. On the next video we're talking about the math behind this. You obviously needed to know what significant figures were first. So that's it.